You've seen the pictures. That rust-colored desert stretching into pale pink skies. The dunes, the canyons, the polar caps. It looks almost peaceful, almost like somewhere you could go. Elon Musk wants to send 1 million people there. NASA wants boots on the ground by the late 2030s. Thousands of people have already volunteered for one-way trips, knowing they'd never come home. But here's what nobody puts in the recruitment brochure. Mars is not a frontier. Mars is not a backup plan. Mars is a place that, the moment you arrive, begins actively trying to kill you, and it has dozens of ways to do it. This isn't science fiction. This is what every serious researcher studying human spaceflight already knows. So let's talk about it. Let's talk about every single way the red planet would murder you. Chapter 1. The journey. Before Mars even gets a chance to kill you, the trip there will take its best shot. You're looking at roughly 7 to 9 months locked inside a metal tube smaller than a studio apartment. And during those 9 months, you are getting blasted with radiation. On Earth, our magnetic field deflects most cosmic rays and solar particles. In deep space, there's nothing. You'd absorb roughly 60% of NASA's lifetime radiation limit just getting there. That's a measurable increase in cancer risk before you've even landed. Then there's microgravity. After a few weeks in 0G, your bones start losing density at about 1% per month. Your muscles atrophy. Your heart, which doesn't have to fight gravity anymore, literally gets weaker and changes shape. Your eyes deform from fluid pressure shifts. Astronauts come back from the International Space Station with vision problems that sometimes never fully resolve. And the ISS is just 250 miles up. They can be home in hours. You'll be tens of millions of miles from any help. If something goes wrong, mechanical, medical, or psychological, nobody's coming. A radio signal to Earth takes up to 22 minutes one way. A real-time conversation is impossible. You are alone in a way no human has ever been alone. But let's say you survive the trip. You enter Mars's atmosphere, slow from 12,000 miles per hour to a survivable speed using the famous 7 minutes of terror descent sequence, and somehow stick the landing. Congratulations. Now, Mars gets to work. Chapter 2. The air that isn't. Step outside without a suit and you're dead in about 2 minutes, but it won't be quick or peaceful. The Martian atmosphere is roughly 96% carbon dioxide. The atmospheric pressure at the surface is about 0.6% of Earth's. That's so low, it's medically equivalent to being in a vacuum. The water in your saliva, your eyes, the moisture in your lungs would start to boil, not from heat, from pressure. It's a phenomenon called ebulism, and it would happen to you on Mars at noon on a sunny day. You wouldn't suffocate first. You'd suffer hypoxia within about 15 seconds, lose consciousness, and your tissues would begin to swell as gases escape solution in your blood. The cold would set in. Frostbite on any exposed skin. Your eardrums would likely rupture from the pressure differential. Within 2 minutes, you'd be brain dead. So you wear a suit. Fine. But that suit has to be pressurized, climate-controlled, oxygen-supplying, and absolutely flawless. A single tear, a single failed seal, a single cracked visor, and Mars finishes the job in under 120 seconds. Chapter 3. The cold. The average temperature on Mars is around -81 degrees Fahrenheit. That's the average. At the poles in winter, it can drop to -220. Even at the equator, on a summer day, the surface might warm up to a balmy 70 degrees, but 6 feet above the ground, still freezing. The atmosphere is too thin to hold heat. The temperature differential between your feet and your head can be 50 degrees. This wreaks havoc on equipment. Metal becomes brittle. Lubricants freeze. Batteries lose efficiency. Habitats lose heat constantly and require enormous amounts of energy just to keep their occupants from freezing solid in their sleep. And speaking of energy, where are you getting it? Solar panels, mostly. Which brings us to the next problem. Chapter 4. The dust. Mars is a dust planet. The entire surface is covered in fine, electrostatically charged particles that get into everything. And every few years, Mars throws a tantrum. Global dust storms can engulf the entire planet for weeks or months. They blot out the sun. NASA's Opportunity rover, which had been operating for 14 years, was killed by one of these storms in 2018. It couldn't recharge its solar panels. It went silent and never woke up. Now imagine you're a human colonist when that storm hits. Your power generation drops to a fraction of normal. Your habitat's heat is failing. Your oxygen recycling systems need electricity. You're rationing energy in the dark, in the cold, hoping the storm breaks before your reserves run out. But the dust is dangerous even when there's no storm. It's full of perchlorates, toxic chemical compounds that, on Earth, are regulated as hazardous waste. They damage thyroid function and can be lethal in concentrated doses. This dust will get tracked into your habitat on every suit, every tool, every sample. You'd be slowly poisoning yourself just by going to work, and the particles are jagged, like microscopic glass shards, because there's no liquid water to erode them smooth. Inhale them, and they shred your lungs. Mars dust is essentially toxic asbestos that's everywhere, all the time. Chapter 5. The radiation. Again. Remember the radiation problem from the trip? It doesn't stop when you land. Mars has no global magnetic field. Its atmosphere is too thin to provide meaningful shielding. A person on the surface absorbs roughly 50 times the radiation they'd get on Earth. Spend a year there, and you've hit the lifetime cancer risk limit NASA sets for its astronauts. Spend a few years and you're rolling dice with leukemia, with central nervous system damage, with cataracts. The only real solution is to live underground or under thick layers of regolith, which means your Martian colony isn't a gleaming dome city. It's a bunker, buried, windowless. You go outside as little as possible, and when you do, the clock is ticking on your DNA. Chapter 6. The water problem. Mars has water. Frozen mostly, locked in polar ice caps and subsurface ice. Extracting it requires energy, equipment, and constant maintenance. If your water extraction system fails, you have days, maybe a week. You can't just drink melted Martian ice either. It's saturated with those same perchlorates from the soil, plus heavy metals, plus other contaminants. It needs heavy filtration before it's safe, and every drop you use has to be recycled. Your sweat, your urine, your breath, all captured and processed. Modern life support systems on the ISS recycle about 90% of water. The remaining 10% has to come from somewhere. On the ISS, it's resupply ships from Earth. On Mars, there are no resupply ships. You either solve the closed-loop problem perfectly, or you slowly run dry. Chapter 7. The mind. We've talked about how Mars kills your body. Let's talk about how it kills your mind. You're 140 million miles from home on average. The sun is a small disk in a butterscotch sky. The horizon is closer than on Earth because Mars is smaller, giving everything a strange, claustrophobic quality. There is no green, no blue, no birdsong, no rain, nothing to remind you of where you came from. Studies on Antarctic researchers, submarine crews, and ISS astronauts all show the same patterns: depression, insomnia, cognitive decline, interpersonal conflict. And those people knew they were going home. Mars colonists, especially on early missions, may not have that luxury. The isolation alone has driven test subjects in simulated Mars missions to break down. Add real danger, real consequences, real distance, and you have a psychological pressure cooker no human has ever endured. Closing. So why does Mars want to kill you? It doesn't, really. Mars is indifferent. The radiation, the cold, the toxic dust, the missing atmosphere, none of it is personal. Mars is just a place that formed without the conditions that make Earth livable. That's the part that should terrify you. Mars isn't hostile. It's just honest. It shows you, with no mercy, exactly how much Earth has been protecting you your entire life. Every breath, every sunrise, every drop of rain. We may go to Mars one day. We probably will. But anyone who tells you it's a backup plan for humanity hasn't done the math. Earth isn't one of many homes. Earth is the only home. And once you understand what Mars actually is, you'll never look at a blue sky the same way again.